Hello students, today we'll see grade 9 physics unit 4, that is work, energy and power. And don't forget to subscribe the channel, like and share the videos, and if you have some questions related to the previous topics as well as on this unit 4, that means on work, energy and power, if you have questions, comment and suggestions, write us on comment.
Okay students, my name is Theorem and I'm your physics teacher. Today we'll see about unit 4 of grade 9, that is work, energy and power. We have some reference or important terms. The first one is conserved property, energy, joule, kinetic energy, the law of conservation, and so on. Therefore, read these keywords by yourself. Let us see. Starting from work done by a constant force. When we say work, as you know, by now there are what many words in physics that have been meaning what well defined, but not necessarily used in way that normally used outside of the context of physics course. For example, work is a certain one of these words, and in physics work is what defined as the scalar product of what displacement and force. And when we say work is done, it indicates that there is what there is transfer of energy. Therefore, when we can say work is done, it indicates that a transfer of energy. When we say work is not done or work done is equivalent to 0, we indicate or we are expressing that there is no energy transfer. Therefore, work indicates or explains the way of energy transfer. Therefore, we can say work is an energy and it measures how much energy is transferred. Therefore, work is the way of energy transfer. Therefore, in normal or in our daily life, when we say work is anything which we lose energy is work in actual situation. But in physics, that's not right. In physics, we can say work is done if there is what energy transfer, and this is calculated by using the scalar product of force and displacement, that means F dot S, and by cancelling this dot we can use Fs times what cos theta, and theta is the angle between the force and the displacement. As you see, the force is exerted to this direction at an angle of theta, and the displacement is to this direction. Therefore, the angle between the force and the displacement is theta. Okay, since work is an energy, it's measured in what? In joules. The second point is work energy theorem. And in work energy theorem, it states that the amount of work done is determined by the change in kinetic energy of a system. This indicates that work done is equivalent to 1/2, or before that, kinetic energy final minus what? Kinetic energy initial, because changing kinetic energy is kinetic energy final over minus kinetic energy initial, and kinetic energy final is 1/2 m times v final square minus 1/2 m times what? V initial square. And by taking this 1/2 m as a common, finally work is equivalent to 1/2 m into what? V final square minus V initial square. Here you must take care when you use this equation. Before squaring, if you subtract, you don't get the real answer. First, you square the final and the initial value. After that, you can subtract from the final the initial one and multiply with 1/2 of the mass. This is the work energy theorem. Therefore, the amount of work done on a system is exactly equal to the change in energy of the system, which is the kinetic energy. And the other thing is gravitational potential energy. First, when we see potential energy and kinetic energy is an energy which is possessed because of what? The movement of the body. Because kinetic energy is equal to what? 1/2 mv square. It is dependent on what? Velocity or speed. Therefore, kinetic energy, an energy possessed because of the motion of an object, but potential energy is possessed because of what? Change in position, because of position of an object is potential energy. Among this potential energy, the one is gravitational potential energy. This gravitational potential energy is possessed because of the change in height of an object, and work is equivalent to what? As we said, force times displacement, and here force is the weight of the object. And weight is equivalent to mass times gravity. Therefore, mg times h is the equation which we use to calculate the work done, and this equation is equivalent to what? Gravitational potential energy. Therefore, gravitational potential energy is equal to mgh, which is equivalent to what? Work done by gravity. Therefore, when you calculate work done by gravity, you can use mgh, as well as if you are asked to determine gravitational potential energy, they are similar. When we say gravitational potential energy, we are saying that work done by gravity. Therefore, the equation is similar. You can use one of the two. Okay. The other thing is conservation of mechanical energy. As you know, mechanical energy is the sum of what? Potential energy plus kinetic energy. Therefore, when we say conservation, the value of mechanical energy of any system is conserved when we say it remains constant, because always the potential and the kinetic energy what? Changes. Sometimes potential energy is changed to kinetic energy. In some manner, kinetic energy is changed to what? Potential energy. The value or the sum of the two never change. Always what? Similar or constant. For example, let us take pendulum. When we take pendulum, at this position, let us say this one is ground. At the ground level, the height is what? 0. Therefore, there is no gravitational potential energy. And if you displace, or if it is moved to this point and released, at this point it has what? Some height h. Therefore, there is what? Gravitational potential energy. And at this point the velocity is 0. Therefore, all energy is what? Gravitational potential energy. And when you release, it starts moving, and the height is what? Decreasing, and the velocity is increasing. Therefore, this gravitational potential energy is changed to, at this point, since the height is 0, all the gravitational potential energy is changed to what? Kinetic energy. And after this point, it keep moving, and when it reaches at this point, it stops. Therefore, at this point when it stops, the kinetic energy is changed to what? Potential energy. Therefore, there is changing kinetic energy. Changing energy from kinetic to potential, from potential to kinetic. But the sum of the two remains always what? Constant. This is the conservation of mechanical energy, or energy is conserved in every situation. Therefore, the sum of the two always becomes what? Always becomes constant. That means, let us say this one is point A, point B, and point C. If you take, or if you are calculating at A, at B, or at C, and let us say this one is D and this one is E, at D or also at E, you can get the same value or similar value of gravitational potential energy plus kinetic energy. That is what? Mechanical energy. But at this point, at these 5 points, the gravitational potential energy is not equivalent. The kinetic energy is also not equivalent, but the sum of the two, mechanical energy, is at any point A, B, C, D, E is what? Constant, or remains similar, because the sum of the two, kinetic energy and potential energy, is unchanged. Okay, let us see one example. A small block of mass m begins from rest at the top of a curved track at a height of what? H, as seen in the diagram, and it travels around a circular loop of radius, how much? R. And this, from this point up to this point, it's what? 2r, because its radius is what? R. And then there is negligible friction between the block and the track between point A and D. A up to D, there is what? Negligible friction. That means there is no friction, but the coefficient of kinetic friction on the horizontal surface from this point up to this point is what? Is mu. And the distance between D up to E is x. And finally, answer all the following terms of the given quantity and fundamental constants. First, determine the speed of the block at B. At B means at this point. To do this, since the friction is negligible, there is no friction, and from A to B there is no loss of energy. That means all potential energy at A, since the height is at this point, the height is what? 0. At this point, the height is h, we have what? Gravitational potential energy. Therefore, this gravitational potential energy at A is equivalent to what? Equivalent to the kinetic energy at B. Therefore, we use the potential energy at A is equivalent to kinetic energy at B, and which is equivalent to 1 over 2 mgh is equal to 1 over 2 vb square. And solving for B, you can get this equation. B, determine the kinetic energy of the block at point C. At point C means at this point. That means at the midpoint of A and B. Since it is energy is conserved, at C means at the midpoint of A and B there is some height and the object is moving. Therefore, they have both potential and kinetic energy. Therefore, potential energy at C plus kinetic energy at C. Therefore, mgh, or the total kinetic energy, is equivalent to mg times twice of r plus what? Kc, kinetic energy at C. And finally, kinetic energy at C is equivalent to mgh minus twice of mgr. This one is the equation which is to determine the kinetic energy at point C. And in C, you are asked to determine the speed of the block at D. D means at this point. Therefore, at D, since the object is moving in the horizontal from B to D, there is no energy loss between A and D. There is no what? Friction. Therefore, the speed of B is similar to the speed of what? D. The speed of D. But at D, you are asked to determine what? Determine the amount of work done by friction between D to E. Therefore, first to determine the force, work done is equal to what? Frictional force times x, and frictional force is equivalent to mu times normal force, and the distance from A to B is x, therefore times x. And finally, you can get this value. And this is the equation which you use to determine the frictional force, work done by frictional force. Find the expression for the coefficient of friction, the coefficient of kinetic friction, mu. We can derive from this equation. And frictional force is equivalent to mass times what? F net, or F is equal to mass times acceleration. From this, acceleration A is equivalent to what? Frictional force over what? Mass. And the frictional force is minus mu m times g over over m. M is cancelled by m. Finally, you can get what? Minus of mu times g. And this minus sign indicates frictional force is always opposite to the motion of the object. And using kinematic equation, that is v square d square is equal to twice of a square. And finally, you can get for mu, v is this much, and we are calculated for acceleration A. Acceleration A is minus mu times g times x. This one is the fifth uniform accelerated motion equation, that is v square is equal to u square plus twice of as. You can use that. And then v at D is this much, and v at E is 0, because at E means at this point the object is stopped, therefore it is 0, and 0 is equal to this much. And finally, this one is minus 2 mu g times x, and you can shift this, you can get twice of mu gx is equal to what? 2gh. 2 is cancelled by 2, and dividing both sides by gx over gx, g is cancelled by g, and finally mu is equivalent to what? H over x. This one is the coefficient of friction equation. And the other thing is power. As you know, power is the rate of doing work, and it's calculated by using work done over time, and its SI unit is watt, and it's symbolized by W, capital letter W. When we say 75 watts, it indicates that 75 joule of energy in each second is used. Therefore, energy indicates the amount of energy used in a second, or the rate of doing work. We have one example here. Some motor is given, and a motor raises 3 kilograms of an object at height h at a constant speed of this much, and the battery not shown in the diagram, which provides energy to the motor, originally stores this amount of energy, all of which can be used to lift the mass. And what is the power delivered to the motor? As you know, power P is equal to what? Work done over time. And work done in this case is what? mgh, because it's lifting the object over time t. And then this one is velocity, therefore mg times what? Velocity v. And we know the mass is how much? 3 kilogram. 3 times h is 10 times what? The height is how much? 0.05. And multiplying this all, 0.5 times 3, it becomes what? 1.5 watt is the power. In B, to maximum height, can the motor lift mass using the stored energy? Let us find h. The maximum energy is this much. Therefore, from this, work is equal to mgh. From this, if you solve for h is equal to w over mg. And if you substitute all values, you can get how much? 0.13. But this is the height which is lifted by using this much energy. And the height of the object is how much? The height is unknown. The height is how much? The height is unknown. Therefore, we are asked to determine the maximum height. Therefore, it needs, or by using this 4 joule of energy, he lifts how much? 0.13 meter of height. And we can derive also for power. Power is equal to, as you see, power is equal to work done over time. This one is equal to, work is equal to what? F times S over time. S over T is what? Velocity. Therefore, this implies that power is equivalent to force times velocity. This one is also another equation of power. Okay, let us go to another point, work done by a variable force. In this case, a variable force can do a work, and to calculate this work done, we use what? Force versus displacement graph. We draw the graph first. For example, we have one graph here. This one is force versus what? Displacement graph. As you see from the graph, you have some segments of the graph. And if you are asked to determine the work done, you must take the area under the graph. You can take the area under the graph. Therefore, to do this, you must divide as you wish. For example, this one is the maximum point. Therefore, this one is the point. And if you need to calculate the work done, you can divide in so many. Let us draw again. This one is the vertical line, and we draw in such a manner, and let us cancel this. Vertically, this one is triangle, and this one is what? Rectangle, triangle, and rectangle, triangle. Therefore, area 1, area 2, area 3, area 4, area 5. If it is such a like, you can divide in such a manner, and finally, work done is equal to what? The sum of these all areas. Area 1 plus area 2 plus area 3 plus area 4 plus what? Area 5. By using your mathematics knowledge, for rectangle, base times height, for triangle, what? 1 over 2 base times height. By making that, you can calculate the areas. And if you sum these all area, you will get what? The total work done of the graph or the variable force. But the graph, if it looks like such a like, you must draw a square, and by counting the segment of the square, you can add and give your final answer. For example, this one is force versus displacement graph, and we can't calculate as a previous. Therefore, we draw what? A vertical line. It has a square. Actually, it has a square by itself. Therefore, for this, you divide or count the undergraphs. That means you take this part of the graph. For this segment, you'll calculate. For this segment, you'll calculate. And for this segment, by making an approximation, you calculate for each segment of the square. And finally, you can sum up and get the final value of the work done. And there are some additional examples. Let us see this. This one is the last example. The example says, let us say the total energy of an object represented by the U versus X graph. That means energy, potential energy versus X displacement graph above is 20 joule for this. And this means that the sum of the potential energy and the kinetic energy of an object is this, how much? 20 joule, even though the potential energy on the graph goes higher than 20 joule. What is the relationship between potential energy and displacement of this graph? They have what? The potential energy and X graph is parabola. Therefore, the potential energy must what? Be directly proportional to the displacement square, or parabolic diagram or parabolic graph is for quadratic graph or x square graph. Therefore, the potential energy has a direct relation with what? Square of the displacement. And what is the potential energy of an object when it is at the displacement of what? Minus 2 meter. Let us see that. Minus 2 meter. Therefore, from this up to this, it is 5, 1, 2 at this point is how much? To do this, at x is equal to minus 2 and go up, meet the graph, and the potential energy is how much? 4. Because when it is minus 2, it is what? The force is also 2, 4, 6. Therefore, it's what? At 2. Therefore, 2 times 2 is how much? 4. mg h. This one is equal to gives us 4. No, this one is not force. Therefore, the potential at this point, this one is 2, 4, 6, 8, 10. Therefore, at 2, it is how much? At this point, it's what? 4 joule. And in C, what is the maximum displacement of an object? The maximum displacement of an object is how much? 6. The maximum displacement of an object is corresponds to the maximum potential energy, and this maximum potential energy is 20 joule. And if you look up 20 joule of a graph, find that the corresponding displacement approximately is what? Plus or minus 4.4. Is that the maximum potential energy? No, the maximum potential energy is around how much? 10, 20. It's what? Greater than 20. But the equation says the maximum displacement of the graph is, in the equation we have what? 20 joule. Therefore, at 20, at this point, it's around what? Around 4.4 or 4.5. In this side minus, in this side plus. Therefore, plus or minus 4.5 is the answer. What is the kinetic energy of an object when it is at the displacement of 3 meter? And the potential energy of corresponding at x is equal to 3 meter is 9 joule. Therefore, mechanical energy is equal to potential plus what? Kinetic energy. From this, kinetic energy is equal to total mechanical energy minus what? Potential energy. And the total mechanical energy is 20 minus 3. The potential energy is how much? 9. Therefore, this becomes what? Kinetic energy is 11 joule. And E, what is the speed of the object when it is at the displacement of this much? You got the kinetic energy. Therefore, kinetic energy is equal to 1 over 2 mv square. From this, v square is equal to twice of kinetic energy over what? M. And finally, v is equal to under radical of twice of kinetic energy over m. And this one is equal to under radical of 2 times 11 divided by what? The mass of the object. The mass of the object is 3. And finally, you got, when you take out from radical, this much, 2.7 meter per second. This is all about work energy and power. Until next time, have a nice time.